Welcome back to Civil Engineering YouTube channel. Today's video we are going to see some important short notes from fluid mechanics. So let's see the points one by one. First of all, Pascal second is the unit of dynamic viscosity. Pascal second is the unit of dynamic viscosity. So what is dynamic viscosity? Fluid viscosity, maybe sometimes we call it as dynamic viscosity or absolute viscosity. It's a fluid's resistance to flow. So viscosity is the fluid's resistance to flow, and which is caused by a shearing stress within the flowing fluid and between a flowing fluid and its container. So dynamic viscosity. Dynamic viscosity is a measure of a fluid's resistance to shear flow when an external force is applied. That is called dynamic viscosity. And viscosity is a measure of a liquid's resistance to flow. And mainly these viscosity are of two types, that is dynamic viscosity and kinematic viscosity. Okay, next point. An ideal fluid is frictionless and incompressible. Ideal fluid is frictionless and incompressible. Next, centimeter square by second is the unit of kinematic viscosity. Centimeter square by second is the unit of kinematic viscosity. And Newton second per meter square is the unit of dynamic viscosity. So unit of kinematic viscosity is centimeter square per second and unit of dynamic viscosity is Newton second per meter square. And kinematic viscosity is equal to dynamic viscosity by mass density. Kinematic viscosity is equal to dynamic viscosity by mass density. So what is kinematic viscosity? It is a measure of a fluid's internal resistance to flow under gravitational force. Kinematic viscosity can be defined as a measure of a fluid's internal resistance to flow under gravitational force. And whereas dynamic viscosity can be defined as a measure of its resistance to flow when an external force is applied. That's the difference between that. And simply we can say that kinematics is the study of motion without regard for the cause, and dynamics is the study of the causes of motion. And we can also say that dynamic viscosity is a measure of force, and while kinematic viscosity is a measure of velocity. Kinematics is a measure of velocity and dynamic viscosity is a measure of force. Okay, next point. Surface tension of water increases with decrease in temperature. Surface tension of water increases with decrease in temperature. Next point. Center of buoyancy is always coincide with the center of volume of fluid displaced. Center of buoyancy is always coincide with the center of volume of fluid displaced. Next point. A floating body is said to be in state of stable equilibrium when the metacentric height is above the center of gravity. A floating body is said to be in a state of stable equilibrium when the metacentric height is above the center of gravity. Next point. Streamlines and path lines always coincide in case of steady flow. Streamlines and path lines always coincide in case of steady flow. Next point, equation of continuity is based on the principle of conservation of mass. Equation of continuity is based on the principle of conservation of mass. Next point, pitot tube is used to measure stagnation pressure. Pitot tube is used to measure stagnation pressure. Next, venturimeter is used to measure discharge. Venturimeter is used to measure discharge. Next point, major loss of energy in long pipes is due to friction. Major loss of energy in long pipes is due to friction. Next point, the losses are more in turbulent flow. Losses are more in turbulent flow. The trapezoidal shape is the best hydraulic section. Trapezoidal shape is the best hydraulic section. Next point, height of the hydraulic jump is equal to the difference in conjugate depth. Height of the hydraulic jump is equal to the difference in conjugate depth. And the last point, Rayleigh lines are based on momentum and continuity. Rayleigh lines are based on momentum and continuity. So just winding up the session. This is all for today's video. Hope you all like this video. If you like this video, please like and share to your friends. Thanks for watching. Stay tuned.